Alright, lesson 6-2, we are going to dive into multiplying radicals, and this is video 1. Alright, so fill these in your notes. So now we have discussed how to simplify radicals. We're going to look at how to multiply these radicals. In order to multiply, you must multiply the coefficient by the coefficient and the radicand by the radicand. And then after you have multiplied the two terms together, you must simplify and then remember to multiply and then simplify. This last little step here, I'm actually going to do an amended version of that where we multiply by writing it like as a product of two numbers because that saves us some time, but you'll see what I mean here in a second. One thing that I like to write, or I at least like to tell my students here, is you can think of this as we're doing outside of the radical times the outside, and the radicand part is going to, so that part, the outside is the coefficient part. The radicand part is the inside or under part, so inside times inside. Okay, so let's look at an example. So example 1 here, I've got 4 as the coefficient and 5 as a coefficient. So you can think of these radicals as like variables. So if it's like the radical of 3 and a radical of 8, these are two different variables. You could, it might be this, it would be similar to say this, to call this 4x times 5y, two totally different variables. I know that this is not x and this is not y, but it's similar to that, where you would just multiply the numbers on the outside and then multiply the numbers on the inside. So here I have 4 times 5, so I'm going to multiply the outside numbers. So 4 times 5 will be 20. And then I'm going to multiply the numbers on the inside the radicand, or under the radical, the radicands, which is going to be 3 times 8. Now notice I did not multiply those out because I'm going to have to simplify anyways. So if they're already written as a product of two numbers, then sometimes it's easier just to go ahead and leave them like that, because I know I'm going to have to break down 8. So I know that 8 breaks down to 2 times 4, and 4 breaks down to 2 times 2. So I can rewrite this as 20 on the root of 3, the 3 that's already there, times 2 times 2 times 2, because that's the same thing as 8. And now we're just looking for, now we have to simplify. So I'm looking for groups of 2 because we are taking the square root here. So I see a group of 2 here. So I'm going to pull out, for every group, I'm going to pull out one of those. So that'll be the same as 2 times 20 on the root of. Now, the 2 I've already taken out, so what's left is 3 times 2, which is 6. And then the last thing is I need to multiply the outside. So 2 times 20 is going to be 40, and then that'll be on the root of 6. So that is your final answer, and 6 cannot be broken down anymore. Let's look at another example. So this example, let me change colors here. Okay, so on this one, we're going to multiply the coefficients times the coefficients, and the radicands times the radicands times each other. So really, the numbers out in front, if there's not a number, it's like multiplying a 1. So here it'd be 5 times 1. So I know the number on the outside is going to be a 5. And then I'm going to go ahead and rewrite all this under one radical. 5 times 3, I could write 15. I'm going to leave it as 5 times 3 as the reduced prime factors here. And then x times y, and notice I wrote y squared as y times y. And now I'm looking for pairs. So I don't see a pair here with the numbers. Okay, so that is just going to change to 15. So now I'm going to go ahead and multiply it out. No pair with the x, so I'll write x right here. But the y's are a pair. So I'm going to bring out a y and then bring that 5 down. So my final answer for this one is 5y on the root of 15x. Okay, one more example here. This example has a binomial times a binomial here. And you're going to do these the same way as if we had a problem like this. I'm just making this up off the top of my head. So recall back when we did the area model, and you would multiply, and you could either use FOIL. I'm not the biggest fan of FOIL, but I'm a fan of using the area model because you can see that when you multiply it, it's going to display all of your products here in a nice grid. So like 3 times 2 is going to be 6, x times x is going to be x squared, and you just multiply all of these out, right? And then you can combine your like terms. But on this one, we don't have x's or we don't have y's or variables. We have radicals. You're going to do it the same way. Okay, so let me get rid of all this. I'm going to draw myself a 2 by 2 box so I have a place to put everything. And I'll put 3 here and then negative 4 on the root of 3a, and then 7 up here, and then 2 on the root of 3. And we're just going to multiply. Okay, so remember the same rules that we did up here when we multiply. So a coefficient by the coefficient and the radicand by the radicand. So we're going to do the same thing here. So 3 times 7 is 21. 3 times 2 on the root of 3. So think of this as like the 3 on the root of nothing, or 3 on the root of 1. Okay, it's we don't write it like that, but there's an invisible root of 1 there. You can think of that, and you would multiply 3 times 2, which would be 6, and then 1 times 3, which will give you the root of 3 here. But I'm going to rewrite this and not have the root of 1 there. So just you can think of it as 3 times 2, which is 6, and then bring down the root of 3. 7 times negative 4 is negative 28. About wrote 27 there. On the root of 3a, and notice I didn't change anything with the root, with the radical here, with the radicand, because it's not being multiplied by anything. Okay, so you just have to think of it as being like a variable, so just bring it with the number. Now this last one's a little different. I'm going to change colors here. This is going to be 2 on the root of 3, and that'll be multiplied times negative 4 on the root of 3a here. So we're going to apply the same rules. Outside times outside, so the coefficient times the coefficient, and then the inside times the inside, the radicand by the radicand. So 2 times a negative 4 here gives me a negative 8, and then that'll be on the root of 3 times 3a. I'm just going to write it as this right here. And so now I see that I have a group of 2 here, and I can pull that out. So that'll be 3 times a negative 8 that's already there, on the root of the a here that's left over that I'm going to have to bring down. And then this multiplies to give me negative 24 on the outside on the root of a. So this number is negative 24 on the root of a. Okay, so now, and at any point, like if I'm going too fast, pause the video, okay, and soak up the information and try to work it out in your head. Pause it, rewind it if you need to. But I'm going to talk about what our final answer is. You're looking for combining like terms if you need to. This is a case, this problem does not have any terms that you can combine. So look at the 21. There's no radical with the 21, okay? So that number, these numbers have radicals with them, okay? So there's no like term with the 21. So I'm going to write down 21. We're done with that one. 6 on the root of 3. This is negative 28 on the root of 3a. Okay, these are not the same. So these are not like radicals, okay, or like radicands. So you cannot combine these two, okay? Same thing with just the root of a. The radicals have to be exactly the same in order to add the coefficients in front. And we'll learn more about that later when we get into 6-3 and talk about adding and subtracting. And this is a good preview to that. But basically, you're just going to add the ones that have the same radical. Well, none of these have the same radical, so I'm just going to write this out. I know it's going to be a very ugly answer, unfortunately, but this would be correct. Okay, and there's nothing else we can do to this one. Okay, this is my final answer. All right, I will see you in the next video. Make sure you try the U-tries, and other than that, I will see you in the next video.